Okay, all right. I think we can start. So welcome everyone to Stateless Influencers call number 47. So as per usual, we'll start off with the team updates. So anyone can just start.
Okay, I'll start, I guess. I've been working on three things in the last 2 weeks. None of them are really ready to showcase. Actually, four things. The fourth one is ready to showcase, and I will talk about it later. But it's been the roadmap, so that's what I'll be talking about later. State expiry, like archival state expiry. This idea I presented a few six back. The implementation is at least of the resurrection is complete. I'm currently debugging it. Then Han wrote the expiry, or at least part of the expiry part. So we're going to merge that hopefully this week. Yep. And otherwise, we're benchmarking the binary trees. We're waiting for DevOps to create a machine for us so that we can bloat it and perform the benchmarks, but the code has been written. Right, and the last thing is the test framework. I think we're gonna hit a roadblock on this one because it requires a huge refactor in their code base. So I've been thinking, and it's too bad that Mario's not here. I've been thinking of actually making a fork of that branch, but I think and just implementing the binary trees directly inside EELS. But honestly, I think at this point we're just as happy producing like blocks in dev mode and sharing the blocks and importing them. At least that will cover the interop. And give the research team, the testing team more time to think about what they want to do and implement it. Yeah, that's it for me.
All right, I can go for Bezu. So in Bezu we have currently two subjects. So the first one is related to getting the pre-images and starting to read those pre-images. So code for has been written but not tested because we did not acquire those pre-images. So now we're looking at using what Ignacio developed with the REST client to actually produce pre-images and go and test our code to consume them. So that's the first subject. The second subject that we have is related to verifying the binary tree and the hash, the root hash. So to do that, we have to go dig out in the code and resurrect like the dev mode option for Bezu, so we can actually generate locally a bunch of blocks using binary trees, and we'll check those. We'll validate those root hashes with Geth. Yeah, so these are two subjects that we are working on at the moment. And yeah, we are not quite ready for binary tree optimizations yet. Like Guillaume said, there's benchmarking. We have some ideas, but we're not quite there yet. So well, hopefully Guillaume, you get some info on this before us. All right.
All right. Any other updates from perhaps MetaMind? I see crash here. Or Ref or Aragon, if anyone from the team is here. Right, perhaps not. Okay, cool. Thanks for the update. Okay, that's all for the team updates. Then we can move on to the next item on the agenda, which is upcoming roadmap update and statelessness implications. So I'll pass it to Guillaume. Guillaume,
Right.
I think
I should have unmuted before. Thank you. Yep. Okay. So I'm going to make a very brief presentation because, because what I'm going to talk about is still, undergoing discussions. But there has been a meeting of the Ethereum Foundation's research team in Berlin at the beginning of January. And turns out I was there, so I joined. There's been some interesting updates as far as Stateless is concerned. So I'm going to share some of that. Unfortunately, I cannot share the roadmap on the public channel like this. They asked to keep it under wraps for now. The main reason is that it's still evolving quite a lot. The parts that we are interested in are not evolving that much, but yeah, overall there's been some discussions. Of course, none of that corresponds to any top-down decision. It's still up to ACD to decide what they want, and I'm sure there will be ongoing discussions for the rest of the month, if not the rest of the year. But the TLDR is that binary trees are finally scheduled by at least the research team sees the binary trees as worth scheduling, and in their proposal that would be for 27 or 20, like late 27, early 2028. I explained the reasons for picking EIP's 7612 style transition. So I think there was a good understanding that this was the way to go. Once again, that doesn't mean ACD agrees. That doesn't mean everybody agrees, but at least there's a good understanding among researchers. And the other notable thing is that state expiry, according to that roadmap, which to be clear is a bit optimistic, but is scheduled for 2029. So binary trees would be in the J star or I star J star fork. State expiry is more like for forks that don't really have letters, but K star or something like this. And I'm going to expand on the state expiry discussions a bit later. When it comes to protocol milestones, there's this is already what I mentioned during my update. We need to do some benchmarking. The reason why this wasn't done is because there was no interest before this, no wider ecosystem interest. And I've always been a bit skeptical of binary trees because I'm not sure how much data needs to be. I'm not sure how much I/O is impacted by the amount of data that needs to be written. So before, to confirm the presence of this binary tree on the roadmap, I have to do some benchmarking, and when I say it's the Stateless team. Carlos is helping me with that, and we're gonna see what the real performance is. Of course, performance benchmarks were being realized before, but they were for vertical trees. Vertical trees have a lot of very nice properties. One of them is that the whole tree can fit in RAM. So the performance was definitely better. But we shall see if what is the hit, if there is a hit, and if there is, what is the performance hit of running binary trees. Clearly, just because the research team is suddenly enthusiastic about binary trees doesn't mean we should be pushing for it if the performance is terrible. Nonetheless, in parallel, we can go back to testnet. So Thomas and Karim have been picking up the mantle on this because Geth was having a hard time merging my PRs, so I had a bit of a bit rot issue. I mean, it's more than a bit. The Vercol PR is completely bit rotten. So thanks to them for that. In the meantime, I was able to merge more PRs, so I would be able to do some testnet. Knowing that we have decided, like I was saying during my my team update, we will need some work done on the EELS side, the execution spec tests. So to do this work, we were thinking of using Geth's dev mode, where blocks are produced every 2 seconds, and we just send a ton of transactions at them. A bit like what we do with bloatnet. So we're just going to do a binary bloatnet, and then we're going to export the blocks and share them between clients. This is a lot nicer for debugging than a testnet. But when we get this interop, I think we can seriously consider having a testnet. Now, it's not going to be as complete as the previous Vercol testnets, simply because there's only a Besu and a Geth implementation of them. But at least as a motivational thing, I think it's quite nice to have. I don't know how much code needs to be rewritten in Nethermind, so I guess we can have a discussion with Łukasz about this a bit later, or Damien. But yeah, like we will not have, no longer have Ethereum JS. We'll no longer have Nethermind for the time being. Yeah. This being said, Nethermind has a code base that was working a year ago, so it needs some refactoring. But hopefully we can resurrect that. I just saw the screaming face of Łukasz, so probably not, but we'll give it a try. One last thing, and it's not it's pretty important. It's about the transition. So once again, expecting a screaming face from Łukasz anytime at this point. But at least I presented the reasoning behind why we wanted to do the transition the way we wanted to do it. And the research team seems to be in agreement that this is a good way to proceed. So we would like to perform a transition, a shadow fork. For this, Besu more or less is ready to go. Yeah, like if we solve the pre-image distribution problem, but yeah, like I think it's more like a matter of getting the data. It's a bit annoying, but it's not impossible. So we should be able to do that. And then do a shadow fork. I have just created yesterday a PR to activate this in Geth. It's being reviewed. Hopefully it will be merged soon enough. And if that's the case, then Geth will also be ready to proceed. I think we will either do something like some dev mode conversion first to make sure that Besu and Geth agree. And when we do, then we can attempt a shadow fork, which we did last time with Vercol. So, Hoodie, Sepolia, and then mainnet, knowing that mainnet is going to take several weeks, probably 2. So we don't want to rush mainnet before we actually are confident that everything works and that there's both clients can agree, or two clients or more if there are more. Yeah, so that's basically it. Oh, right, so that's it for the protocol. Now there's this thing I've been hoping to do for the last 2 to 3 years, but didn't really have time to do. But now there's not really any way to put this on the back burner. It's about bringing the whole ecosystem in into this and collect feedback, make sure that everybody is in line with this, or at least understands the trade-offs. So the first thing I'm going to do, I mean, I'm saying but it's the team, it's stateless consensus. We are going to interview ecosystem players. So who do we mean? Like L2s first, but then dApps and also wallets. Although wallets are less important right now, because we did talk about some wallet people in the past, and they say, well, as long as there's an API, we'll use it. But yeah, L2s and dApps are probably the most important people to bring into the conversation. So we're going to run a round of interviews. We're gonna send people a questionnaire, have them fill it, and then we're going to interview them and make a presentation about what the changes are going to entail, what feedback we can collect. And yes, so if you want to help with this, either by participating in the calls or just you have contacts, because we're looking for contacts, yeah, please get in touch. We would like to try to get a good coverage of the major players of this ecosystem. That was it for the roadmap update. I think I have a follow-up agenda item on the state expiry, so I can do it now, or I can maybe also open the floor for questions if there are any. Okay, so I'll talk about state expiry. Yeah, so when I say state expiry, I mean there's also an update on the discussion that happened last week. Sorry, last week, 2 weeks ago in Berlin at the EF research, and just to give an update on what was discussed there and what is the general outlook of researchers and Vitalik on the whole state expiry thing. So in case you're not already aware, but you should be, state expiry is a bit of a scary topic. And so we like, the reason why it's so scary is, well, first, we're removing data, so there's always the question of who's going to hold that data and how do you get it back. But it's also the UX which is going to be a bit difficult to handle. So there's been some discussions, and let's say all the conversations, all the proposals came into two kind of buckets, two models. One of them is the leaf-based model. So it's the one that let's say the stateless consensus team, but other actors, like for example Alexi back in 2018, have been working on, which is the expiry of leaves. So it's something like 7736, OOPSI, or archival. Doesn't really matter. Like, there's a few design options. Like, do you want to make it in or out of protocol? Do you want to do how aggressively do you want to delete the leaves? Do you want to save them to disk, or still have them on a slower hard drive, or delete them completely? And the other model is called Epoch-Based, and I'm just going to talk about it a bit later. So leaf-based, just as a reminder, well, it's exactly what it says. You delete leaves. So when I say you delete, you remove them from the tree. Where they're stored, this is a bit of an open question. And the problem of the leaf-based is really the resurrection UX. Because you need to pass a proof to say, well, that data was there, and the shape of the proof is really dependent on the way you expire those leaves and where you store them. Predictably, there's a lot of excitement about Stark-based proofs. But yeah, just passing Merkle proofs work as well. And then yeah, you can just enforce them being in an offline store, so they still have to be there, but they're not considered part of the tree. So if you want to resurrect it, you have to somehow send a signal that they have to be resurrected. And yeah, the biggest problem is who's going to be holding the state. Some conversations well, there were some discussions in Berlin and before, and the answer is that it's probably going to be wallets. And the reason for this is because those wallets, they are the ones making most of the money in the builder centric world. This is something I learned recently and was quite shocking to me. So actually, the block builders themselves, they're not having so high a margin, because most of the money they make, they send to wallets, so that wallets send them the transactions. So if that model really holds, then we could potentially expect from the wallets to hold that data and to provide the proofs. First, because well, they would be the ones profiting a lot from this from holding that data. And second, because this is where the UX problem really is solved, namely that the user could just say, okay, I want to send my transaction from this account I haven't touched in 5 years. And then the wallet will say, well, it's going to be a bit more expensive because it's that data is cold. So be aware, like, to you, it's just still a transaction. You sign that transaction. And then when we know you signed a transaction, we're going to demand a higher price, like a resurrection price from you. And then when you sign a transaction, we have this transaction. We will first send the proof to resurrect the state that you need. And when we resurrect, like, the cost of this proof is provided by the increase in the transaction fee, the resurrection fee, you could call it. And then once it's resurrected, forward the transaction. So that would be a good model. Of course, it's not perfect in the sense that wallets could also be censored. But at least in terms of general UX, if you are not being censored, your UX is not affected. Okay, now I want to talk about Epoch-Based, and once again, it's I apologize for those horrible scribbles that I had to do, but I was a bit short on time. So the idea of an epoch-based state expiry is that really you don't really expire anything. You just have a first tree, and then in the second epoch you have a second tree, and then let's say we're at the third epoch, you have a third tree, and when you want to read something, you just read the data, and if it's not present, it's not present. But so that means only this tree gets updated as the chain progresses, so the performance is kept at a manageable level. Now, what they suggested is this idea where each tree, on top of having each expired tree, has a resurrection bit. Actually, it's a bitmap, yeah. And each node in each leaf has a bitmap. So if, for example, I want to resurrect this leaf here, I would go to the bitmap. The bitmap has to be 0, and then I set it to 1, and then I go here. I also provide a proof. So okay, I had to provide a proof that it was part of this expired tree from epoch 1. I also have to provide a proof that not only epoch 2 did not contain my value, but also that if it did contain my value, it was not resurrected. It has to be both. Otherwise, you could resurrect items from older times. And yeah, so you update, like you mark this value as 1, and then you add it, you resurrect it, you bring it into the current epoch tree. This has some nice properties and some not so nice properties. The not so nice property is that those epoch trees are not really frozen, right? They get updated. It's not technically the tree that gets updated, it's the bitmap. But yes, you need to keep a hash of the bitmap for every epoch. So your block is going to grow every time by 1 hash at every epoch. But the other interesting approach to this is that there's no address space extension, which was always plaguing all the designs of multi-epoch trees. So they found a way to get rid of that. One thing I didn't write, which is also quite interesting, is that the size of your proof, of your resurrection proof, is effectively like logarithmic. Well, it's k log n, so k is the number of epochs that you go back, and log n is the size of the amount of trees of leaves inside a tree. So it's not scaling like you have a sublinear scaling. I mean, you have linear scaling in terms of epoch, but a sublinear scaling in terms of data. And as always, you can Stark it. So that was very exciting to some people. Yeah, the problem is technically you're expected to keep all the trees or all the time. So that's kind of manageable because once again, you can have these resurrection fees. You can have a UX that says, well, if you haven't touched your account in 5 years, you can afford to wait another 10 minutes for your data to be resurrected. So all those schemes with wallets and potentially getting data on the network with rewards, associated rewards in a rainbow staking kind of way, are totally manageable. But yeah, per se, everybody is expected to have every epoch, so the saving is not the best. One remark is that, and this is an idea that initially came from Karim, from Besu Karim, is that when it's just a read, you don't have to have all the trees. You can just merge all the expired values into a single flat database, because presumably you're only interested in the latest time your account was touched. So you can do something like this. That's to serve reads. For writes, you still need to do the resurrection. And in both cases, you still need to do proving. But if you have, like, let's assume your node is behaving well, then everything that is in the expired flat database will be the correct data. So you don't really need the proof to produce the block, at least, although you might need it to verify. Yeah, I think that was the last slide. Yep, so that's it for the update.
Okay. Lukash has a question. So he asked, like, why can you expire dash drop epoch price? So maybe you want to elaborate. Yeah.
Is the question why can you or why can't you?
Can you?
Should be why can't you, I think, right? Because sorry.
Yeah, you cannot do it simply because if you do, you need to let me rephrase this. It's connected to an address space extension. If you need to, I mean, okay, I guess you could expire all the old trees. Simply oh yeah, sorry, I'm mixing two things. Yeah, so well, in some models you can, but then to resurrect you need the proofs. And in some models, you are expected to do exactly like the overlay tree, where you first hit the current tree and you can read the old tree. So okay, it's only in that model that you cannot expire the.
Okay.
Yeah,
Okay.
my bad. My bad.
So if we could expire, can we like freeze the old trees? Could be frozen and like this stored somewhere, distributed somewhere like BitTorrent, whatever, right? Similarly to 4.4s. And
Yes.
this could be okay. So this sounds like a win to me, to be honest.
Yeah,
This is
the only
model I
problem.
would prefer.
Okay, well, you're not the only one. The only problem with this is I mean, it's the same as the other one. If you do this, then you have your resurrection UX, which is just as bad as the other one, because you need to pass proofs all over the place, and it needs to be resolved. But it's true that yeah, you could. Okay, yeah, I've been mixing two things, but come to think of it, it's not bad at all. Yeah.
Yeah. So my concern is I wouldn't rely on a third party to store the state. Like it can be the fast path, right? But I would love to have a way to actually, a backup plan.
Oh yeah.
And this sounds like a backup plan to me in that way that this can be like shared on literally like few copies of that on the internet on like BitTorrent or something, and someone, oh, my wallet screwed me, and I'm not out of options. I can always download this huge file or whatever, or pay for some service to do that for me, and it will get this file, produce the proof, and give it to you, and now I can get my money back.
Yeah. So just for one interesting, well, something of note at least, is that they want those trees to be 5 terabytes on average. So if you have to download multiple times 5 terabytes, that's going to be a potential problem. But yeah, I mean, if that's the size of the state, that's the size of the state. And the other thing I was thinking of, yeah, my only issue with this, like BitTorrent, in my view, is not good enough because people will tend to drop data. Like, yeah, there's so many trackers on the internet where you try to download a movie, completely legally, of course. You try to download a movie, but most people did not even hold it. Like they had it at some point, but so it's still advertised, but they don't actually have the data. And this is, in my view, a terrible. I mean, we don't want that to happen. So I think like my preference would be to have something like rainbow staking, where there is actually a role where you have to provide the data if being asked, and you get rewarded for it.
Quick questions. Why 5 terabytes? Why such big number?
Well, there are several reasons. First, because 8 terabyte disks are still pretty new, or at least 8 terabyte SSD is true that you can have petabyte HDDs, but most people don't have that. The other thing is that there are there's a lot of ISPs that actually limit the amount of data you can download in a month. For example, we looked it up. Starlink, I think, has a limit, could be wrong, but has a limit of 2 terabytes or 3 terabytes, which means that if you want to download your data and you have like 5 epochs to download, so that's 25 terabytes, you need about a year to download all your data.
Got it. And you would have to download all the epochs, right? Because you need to prove that it didn't change in the later epochs. That's the
exactly
case?
Yes. Like if you have to do everything yourself, of course. If you can get someone to send you a Merkle proof, it's a lot better.
Mm-hmm. Right.
Yeah, and like Carlos says, for sure, like all those limits are going to improve. There will be more. I'm sure we'll have 16 terabyte hard drives in a few years. But the thing is, if more people use Ethereum, we're just going to be chasing that limit, because as soon as the limit rises, the demand is going to rise as well. Well,
okay. I have another question.
Mm-hmm.
But this would have to be sponsored, so would have to be somehow. I doubt entity that is like commercial would ever do this. But yeah, still, let me ask the question. Could we somehow proactively generate those proofs when we expire things, especially if we expire accounts that are EOA accounts? Okay, now with account subscription, it's really gets complicated, but
it's like account abstraction is not the problem. The problem is that the root will change for every new block or epoch, and so you will need to constantly update. Like when the epoch changes and the new tree comes up, what do? You provide the new proof for absolutely every expired leaf for everyone, because it will change, right? All the other proofs go stale.
I mean, it's doable, like to provide a proof for every single value in the tree, or at least a range proof. The thing is, if it's just one proof per tree, it's a lot more data. And the question is, who's going to hold even more of that data?
I don't know. I'm just
and like I think it's not a stupid question at all. It's just I think it opens a lot more questions that I don't personally have an answer for.
Yeah, Carlos?
Yeah, I wonder. I've been thinking about this lately, and I wonder if we should see state expiry more from the perspective of actually getting rid of data and forgetting data than actually a revival mechanism that we can use sometimes and this kind of stuff. What I mean is, we, from the protocol perspective, just leave the gate open for revival because we need to do that. But in reality, the way that we look at state expiry is just the more data we can just crash and forget forever, the better. And if there's companies that get a profit from actually storing all of this data and providing proofs for revival, I mean, nice. But kind of looking at it more like we will crash some people, and that's true. I mean, and I think that's inevitable anyways. But the positive between quotes thing is that at some point we will get a mind change between users, where actually we all understand that they need to start storing this data, or it's used constantly, because Ethereum will just be hot state and cold state will be just you are on your own basically, and if you don't have anything to revive it, you can say goodbye to it. Like, we're super scared, or at least I am, about being that explicit, but it might make our lives significantly easier, because all of the discussion about the terrible UX for reviving and all that stuff, it's like, yeah, sure, it's really bad, but the intention is not to revive, it's to actually destroy as much data as possible. Maybe this is too radical, but I want to see what are the thoughts of this perspective.
So yes and no. So I do agree that Ethereum probably shouldn't give guarantees as a chain, but we should probably make this as easy as possible, right? So if I could, for example, at some point in time, also say I want to download proofs for my account, let's say, right? And it just gives me everything I need. And I can store that somewhere in my cold storage. And I know I'm fine, because even if I forget to, keep this account hot for the next 2 years and it expires, I can just bring that back and, and I'm fine. Then it's good. But if we don't provide this kind of really good mechanism that, for example, wallets could integrate or someone could integrate easily, I'm afraid that we will hurt people.
I mean, notice that it's significantly easier to revive accounts than it is to revive contract storage, right? Like holding the entire account tree subset, it's about 14 gigs as of today. So 14 gigs, you can even hold it in your ZK EVM node in the future, right? I don't think we should suffer that much about accounts, because that's data that it's likely going to be significantly replicated across the network, even if we don't have full nodes anymore. I think the bigger issue is contract-related data. And this is a big issue anyways, because ERC20s store your balance inside of them. So
yes,
if you expire that, you're fucked.
Exactly.
But I think there's some proposals from Vitalik and Han, which actually might be trying to tackle this a bit. So maybe this circumvents a bit the problem. But yeah, I agree. There's no silver bullet solution for that. So as I said, maybe it's time to start making people understand and dApps understand that they need to actually keep somehow a partial stateful node or something like that, where they are constantly capable of producing these proofs for people, for example, or stuff like this. Otherwise, it's impossible to maintain tens or hundreds of terabytes always available for people to generate proofs at very low cost and really easy UX and all this kind of stuff. I don't see the way.
By the way, how did we get to the number of tens of thousand terabytes when we are less than 200 gigabytes at the moment?
Well, if we follow the roadmap, the idea is to be at gigagas by M-star, I think it is. So gigagas, a block that does 33% of storage. We're talking about 333 million gas just on S-store, for example. And this is on the use cases that we have today. If people start tokenizing like maniacs, maybe we deploy a lot more. So we could easily see more than 100, 200, 300 gigabytes a year. And if Ethereum is meant to be running forever, at some point we will hit these rates. So that's why I said on top, people love to throw this hardware will improve fast enough, so we don't need to worry about it.
That's true.
But yeah, I mean, I also think that at some point there will be limitations. So
well, we already hit limitations of cost per gigabyte, not to mention the current crisis reversing that trend.
I totally agree. I totally agree with you. It's not that I support this argument, just to be clear. It's just that this is the classical argument that people throw. So yeah, I go to the extreme then, and I'm like, okay, sure. Even if we can handle 10 or 20 terabytes, there will be a point where this is completely unsustainable, and there will be no way. So we anyways need to prepare for that.
Okay, so let me ask one more question, because currently we want to cap state growth a bit, right? So where comes this 100, 300 gigabytes? Will we uncap it? Will we make it cheap enough that we will have so much state growth?
So if 8037 gets, I assume will get included. At least that's my understanding. We will probably see an increase of 100 gigs per year, or at least I think that was the target. But I'm not sure we can run with 8037 forever, right? Like if BlackRock or companies like this want to start tokenizing stuff on top of Ethereum mainnet, we cannot be like, hey guys, it will take you 1 month just to deploy the shares, or I don't know, whatever financial asset on chain. Like it's really bad. I don't think that works. So I think A37 is just a way to put a hold on state growth while we actually figure out what's the best way to move forward, because I don't think we know yet. But I don't think 87 can be here forever, at least if we want to support some of the use cases that I see mentioned in Twitter and in these kinds of places.
All right, nice. So we have 10 minutes left, and the last item on the agenda is a presentation by myself. So I'd like to present like a very early stage idea, which is inspired from Vitarik's idea, which he presented 2 weeks ago in the last SIG call. So I'm just gonna do a very quick sharing. All right. So, right, yeah. So just do a recap for those who are not who didn't join the call for the last 2 weeks. So basically, Vitaly presented a new idea on user associated storage, where so the TLDR is that this is on binary try. We'll basically update the header in the binary try for each account to include 16 slots of what we call privileged user storage. So basically, this storage will most likely be like your token balance or something that you use very often as a user. And the whole goal is to the first thing is to associate storage to a user, and which will make the gas costs cheaper, and it's also quite friendly for state expiry or stateless proposals, because like the current problem is that we have all these balances like distributed across like different tokens in their own storage. But if we associate it with like in the accounts header, then that would be much nicer to expire compared to like randomly distributed. So that's the initial idea. So I'd like to expand on this idea and make it I mean, here I call it address-based storage, but the idea is quite similar. It's also it's also based in binary try. So so the status quo of the contract storage using Zen as an example. So if you study Zen's contract, so for context, Zen holds the largest contract size in the current Ethereum mainnet state. So I can actually show you what's the difference between the first place and second place. So if you see here Zen Crypto, right, and you look at the slots, so Zen currently has, like, this is real life, I mean, like real-time data. So it currently has almost 141 million slots. And the second place is USDT, which is 21 million storage slots. So that's like 7 times, Zen is like 7 times larger than USDT. And most of it is because of what I would say badly designed storage layout, but maybe we can't stop them from doing that. That's just how it is. But the point is that when they have this mapping of address to a struct which holds 6 32-byte values. So what happens underlying is that all of this values, six values per address, when we insert it into the state try, it will basically, when we generate the or when the bytecode generates the SSL keys, how it works is that it will hash the address, and then concatenate with the storage layout index, and then it will hash it. So the result of hashing it is that when you insert it into state try, it will be scattered around, right? So that means you wouldn't have the good locality because everything is hashed. So the idea is that we want to group this similar storage together, because when you are reading this struct per address, you are most likely reading everything in one go. So for ERC20, there will be like your balances and allowances. So most of the at least based on the current pattern, most of the contract storage is based on mappings of address to some value. So also for context, a mapping of ERC in ERC20s, mapping of address to balances take up about 30% of, at least 30% of the current total storage size. So that's why these mappings should be optimized. So what I would like to propose is something like basically what we have right now, similar to what we have right now with the account try and storage tries, but in binary try. So originally in binary try, we don't have a separation of storage try and account try. Everything is put into the single unified tree. But for address-based storage, I would like to change this to introduce a second tiered storage. But this is not the contract storage, but more on address-based storage. So meaning we will move like per user contract state from the contract storage into the user's account. And this is namespaced by the contract address. So for example, if you have an EOA, then instead of storing, so you have an EOA, you have an account, you have you hold multiple tokens. So for example, DAI, USDT, USDC, or whatever. So instead of those storage being stored in their respective contract storage, you store it actually in your storage. So that's the general idea. There'll be more details, which I'll publish in the article soon. But so if you go back to the Zen example, so this is like bad. I mean, keys are scattered, no locality, and it makes try larger because everything is random or everything is distributed evenly, and then you grow your try, which is bad for IO and so on and so forth. So if we apply this address-based storage on using Zen as an example, then that means that in the binary try, because we are grouping values together, we can actually store all of this in a single page or single leaf node. So when you are reading this page, you are reading it in one go. So that's more efficient, right? At least for this use case. So just to go through, that's basically the gist of the ideas. Again, there will be more technical details. But the pros of this solution is that first, you get locality, which is more efficient. And better locality will lead to lower gas, because if you are reading multiple values per address in one go, instead of doing, for example, multiple S loads, you can only you'll be able to do just like one. You load it once and it's already warm for the rest of the other values, so it's much cheaper. And this proposal is also compatible with proxy patterns, so it won't break the existing patterns. It's also compiler friendly because, I mean, contract developers don't really have to know if they should use this or not, because the compiler can just determine that, oh, if this is the mapping of address to something, then use this new opcode that we will have. And it's also state expiry friendly. So assuming that every contract storage is stored in this, I mean, every token balance, for example, is stored under your account instead of contract storage, then we wouldn't have to deal with like the UX issues of having to revive your balance in this contract storage. So that's more friendly from an expiry perspective. And from a stateless perspective, it's also friendly. So if, for example, if you want to run a partial stateless node, so you only need to know your account and the account storage, meaning the token balances, and it's much cleaner and simpler to do it compared to having to store the whole storage of the, for example, ERC20 token that you care about. So yeah. And the downside of this proposal is that it definitely adds witness overhead for zk-EVM. This would probably be my main concern because we are introducing this second tiered storage try again. And the second thing is also a complexity, because we are introducing somewhat like a new class of state. So it's going to be a pain for EL client developers to implement, at least in my view. And it's also only applicable to new contracts. So that means that the existing USDT, USDC contracts wouldn't be able to migrate. Because if they want to migrate to this new contract, they will have to migrate all of the storage, which is not feasible because they will have to have the pre-images. So I don't really see a way of doing it. So yeah, so that's just an early idea on how this address-based storage works. So yeah, okay, I think there's a hands up. Carlos?
Yeah, thank you for the presentation. Are you like there's literally no way to do this migration for everything? Like, aren't there any ways to I don't know, upgrade the contracts or yeah, I don't know. It would just be really nice if we could do that, because if we are able to transfer all of the valuable assets from users to the account, then as you said, expiry becomes significantly easier to do. So yeah, have you thought this thoroughly, or are there any hopes that maybe we
I
can
think
do
it's really difficult from a protocol perspective, because you even if you have the pre-image, you need to have the pre-image of the pre-image, because like when you're storing a mapping of address to some value, it's hash first, and then we're inserting to the trie, you will have to hash it again. So now for binary trie, we have the pre-image, which will give us the SSStore key, original SSStore key, but this SSStore key is hashed with the address concatenated with the storage layout index.
I see.
So you have to, yeah, I wouldn't say it's like not, it isn't impossible. It's just that I think contracts that wants to do something like this, I think it'll be up to them to do it, because they can do a static analysis on their storage layout and then get all the pre-images and then maybe pause their protocol for one day, I don't know, then do the migrations to the new contracts. But it's going to be very painful, and doubt that they are going to do it unless the future cost of SSStore is so expensive that they have no choice but to migrate to this new type of storage. So yeah, that's why I said this is downside. So
yeah, thank you. I mean, the only issue is that if this remains, then the problem is we have two different places where the data can be, and they both need to match, most likely. I mean, I don't know, but yeah.
Lucas.
I have a different question, because this by design is very limited storage, right? Only like few slots kind of storage, right? Few values.
We did think of bounded key, but I actually just reverted to unbounded. So meaning that like every address and every contract storage would have its unlimited space of storing. Like basically you can store how many as many slots as you want in this address-based storage.
Okay, got it.
Right. And
we're a bit over time, but just a quick question. Why do you need the subtree? Why don't you just use another, like the storage? We just add a huge number in front to make sure there's no collision. But why don't you just leave it at the same level as the regular storage? Because it is storage after all. And in fact, an account having its own storage will not have that's not true because of 7702, but you won't have a collision, otherwise that means you do find a hash collision. So why do you need to go through a subtree when you could just put it at the same level?
From my understanding, that would clash with that would have potential collision with the main storage, right?
I mean, yeah, sure, in theory, but that means if you do, that means you do find the collision to the hash function. So no, I mean, it's plausible, but it's very unlikely.
Okay. I mean, that would be much nicer because we don't have to do in the subtree. Yeah.
I understand this was for preserving structure, no? Like in binary trees, we lose any kind of structure that we can possibly have. So it's very hard to reason about what an account is and what is not. But if we have the subtrees, then it might be significantly easier to actually make these reasonings.
Yeah,
I might be wrong though.
Yeah, I don't think so, but let's take it offline. We're over time.
Okay. All right. So that's all for this meeting, and we're over time by 4 minutes. Sorry about that. But yeah, thank you everyone for coming, and I'll see you in the next SIG call. All right. Thank you.
Thank you, Han.
Bye.
Take care. Bye.
Bye.
Bye.